In this short, rather nice construction and useful one associated to the hyperbolic geometry. Okay. So firstly, what is the circle at infinity? Well, in the Poincare disk model, that is the unit disk, well, that's the D. This is hyperbolic plane. Well, this is the circle at infinity. There's nothing to say about it. It's a circle. What about the upper half plane, H? Well, remember this corresponds to the circle at infinity by the map z minus I goes to z plus I. So in this case, boundary of H is going to be real line, but also a point infinity. Okay, and remember under this map, infinity maps to the finite point 1. So I can regard S1 as being the boundary of disk, and R union infinity, which is a topologically the one-point compactification of R, as being the circle. Okay. Now what can we do with this? Let's just look at geodesics and S1 infinity. Let's look in the disk model first. Okay, so let's take a geodesic. Recall what that is. That's a pair of points here and here, and an arc joining this, which intersects the boundary at right angles. Well, what does this mean? Well, remember that this means, of course, that the tangent to this circle is perpendicular to the tangent to the other circle, okay, to the circle at infinity. And so the radial vector to this circle, the circle of which this is a chord, is going to be perpendicular here and here. So the circle has a center at the intersection point of these two red lines. Okay. So now you can see from this construction that as soon as I had this chord, I could find a unique point at infinity. Okay. Sorry, I could determine a circle corresponding to it. Okay. So what this tells you is that there is a bijective correspondence between geodesics and, well, S1 infinity cross S1 infinity, well, not exactly, if I have to have oriented, so minus the diagonal goes the reversing symmetry. Okay, so this is the point. Given a pair of points at infinity, I can do this construction and find something that intersects it at intersects a geodesic joining these two pair of points. So that means it's an arc of a circle which intersects these orthogonally, and this is a canonical construction. So this is a natural one-to-one correspondence. There's one more case to consider here, which is that I have a pair of points so that the two lines that I have drawn here, the red lines, end up being parallel. Well, when does that happen? That happens exactly when the line joining these two passes through the center of the circle. Okay, in that case, this is the unique geodesic joining those two, and it happens to be a diagonal. Now no other chord works because no other chord is actually perpendicular to both endpoints. Yeah. So in either case, given a geodesic, you get a pair of points which it ends, but given a pair of points, you can canonically associate to it the only geodesic that passes through them.